last few months, CaddX has spoke quite a lot about their new upcoming drone and digital FPV system. Alongside the CaddX stuff, we've also had leaks. We know the name of the drone is going to be Protos, the new system is going to be called Ascent, and we've even seen images of the drone, the FPV board itself, and footage from some of the testers. CaddX have now stated that this product will officially launch on the 20th of October, and alongside that we've now got a lot more information not only about the pricing of this product but also what is actually going on below the hood. Now, just to be crystal clear, I am not involved in this launch. I don't have this product. There will be no review from me on this product next week. I won't be getting my hands on this until I'm able to actually go out there and buy it. But that doesn't mean we haven't been able to learn quite a bit about what's going on, including the truth behind what this new digital FPV system really is. Now, today, CaddX have dropped their first proper bit of marketing on the lead up to the launch, stating that the Protos Ascent, powered by the new Ascent digital FPV system, is going to launch on the 20th of October. Now, this image here doesn't really tell you a lot. However, Google does, because if you actually do a little bit of digging in Google, you can actually find quite a bit more information on this drone, including the price of the kit, which is going to be $359, and some more images of the drone, the goggles, and the remote controller as well, including some pretty big close-up images of the product that's set to release. The first thing that you will notice is that the goggles on this are very much a reworked version of the CaddX Goggles L. The drone itself is a bit of a cross between the Defender 25 from iFlight, the GoFilm 20 from CaddX, and maybe even a bit of the DJI Neo, although the information I have is this is very much designed to be an FPV drone. It doesn't record on board. It doesn't have cinematic style features. It's really a product that is designed to offer an FPV experience for new users. It's based on firmware, which we believe is PX4. That isn't 100% confirmed, but that is the rumors that are going around. It does have things like visual positioning system or optical flow, depending on what flavor you want to call it today. And obviously it's designed to be used with its remote controller based around ExpressRS. And in fact, you can connect a normal ExpressRS remote controller to this drone as well. And then obviously it's got that digital FPV system in connecting to the goggles. Something just to be clear on as well, this system, this drone, is not compatible with any of the existing Avatar HD system. You cannot use this drone with the Goggles X. You cannot use it with the existing Goggles L. There is no cross compatibility between the existing Avatar HD system and this. It is designed to be an entry-level product. Pricing at the moment looks around that $360, which is incredibly aggressive based on what you would pay for something else like this, but it isn't a direct replacement for the Avatar HD system you see today. As I've mentioned, the drone does have features like optical flow, and it is based around proprietary batteries, which will limit its use case, but again, making it a product that really is designed for new users rather than the existing FPV community. Alongside all of the other leaks, we have also seen some footage of this product from Tom. Tom, TMC-FPV, has been actually testing this, and he's got some Protos video on his channel. I can't comment on how it's been uploaded compared to how it will look to you through the goggles itself. However, what is really interesting in this is the RF behavior of this system in different scenarios. He specifically shows some of the low RF signal behavior from the system, and you get to see how it behaves as the signal drops. You see the system go from color down to black and white, and then you actually get the image drop down to this center section, this quite interesting focus style mode that they have integrated into it. What you will notice in the footage that he's released is that it has a maximum bitrate of about 20 megabits a second. I haven't seen anything go higher than that. If we then move through the footage, you can see you'll start to see this focus mode appear on the side. It then goes to black and white. Here in this other bit of footage, you start to see it behave. It goes into the focus mode, black and white, and then this center section in the middle of the screen. Again, really interesting, completely different from anything else that we've seen on the market before. And I'm really interested to see how people find not only the black and white behavior, but this dropping down. It seems to have multiple stages of low signal behavior. So you've got a standard focus mode, black and white, and then reduced down to the center section. These leaks have been taken from Google, and the pricing right now is showing up at $359 for this kit, which is going to be incredibly aggressive. However, this in itself isn't the interesting stuff. The interesting stuff is the new Ascent HD system. The existing Avatar HD system has been based on chipsets from Artisan. Artisan are a company who make chipsets for many different applications, but their RF chipsets have been widely used in products including early DJI drones, such as the Inspire 1 and the Phantom 3 series, as well as more recent drones from the likes of Husband, Potensic, and a number of other companies. Artisan's AR-Link series of chipsets have popped up in all sorts of applications, and as one very good person I know said to me, they are pretty much the only option out there when it comes to doing this kind of wireless digital link that isn't Wi-Fi, that isn't a complete in-house custom chipset. Now, this has been something that CaddX have tried to hide from us. Early versions of the goggles, they actually labeled this chipset as a Xilinx FPGA, and then in later versions that was just completely masked. But very early on, through the amazing work of the FPV WTF team in Junus, were we able to identify what CaddX was doing in the Avatar HD system. If we hop over to my FPV wiki, here you will find teardown images of a lot of the products that I talk about on this channel. I try to upload as much as I can, including the teardowns from the Avatar HD system. If we take a look on that page, you will see we've got some nice images of the Avatar VTXs, and here you will find the chipset that CaddX have been using, which is the Artisan AR-Link 9201 series. Now, this is a bit of an all-in-one chipset, quite similar to what DJI was using in the original FPV system. Just to be clear, DJI are using their own in-house chipset, and they are not the same. They are not identical. DJI is far more customized, whereas this is a customized ASIC derived from WiMAX. But this does allow CaddX to build an FPV system based around the Artisan AR-Link system. This main chipset that you see here has a number of different parts on board. It has the main microcontroller, which runs the Linux OS. It has the RF baseband on board, and then this is paired up to another chipset, which is basically an RF Mux chipset, basically the same as the IE1000 that DJI use, but we believe this instead is actually an Artisan chipset that then connects up to the power amplifiers and generates the RF waveform. The one thing to understand about what CaddX was doing with Avatar HD is that it wasn't an in-house, completely self-developed system. They took what was an existing system based on AR-Link from Artisan and packaged it as the Avatar HD system, largely basing it off the Artisan SDK. Now, just something I want to stress at this point that is relevant to what we're going to be talking about is the fact that the chipset that CaddX used in Avatar HD is that somewhat all-in-one. It is the main microcontroller, the RF baseband, the modem, and that is all encapsulated within the same ASIC. This is the same thing that DJI did with the original digital FPV system with the P1. However, DJI with 03 and now 04 have migrated away from this single all-in-one ASIC for the microcontroller and RF and have moved now to a separate system which takes the RF system into one chipset and the main microcontroller video encoding ISP in another. And the benefit to doing that is that DJI can pair up the RF and main microcontrollers in different configurations. So for certain applications, they can pair the RF modem with a really beefy video processor like they might want to use in the likes of the Mavic 4. And then in 04, they can use it with a less powerful microcontroller that doesn't require all of that additional processing needs. What is interesting in this is whilst CaddX are not using this same Artisan chipset, they haven't completely walked away from Artisan because the new system is still based off the Artisan AR-Link system, but instead it is now using a similar setup to what DJI are doing with 03 and 04. If we take a look at one of the leaked images from DIY FPV on the new board from this new drone, whilst we're not able to identify part numbers, I am able to explain to you what is actually going on here now. For instance, on this side of the board, we have the main microcontroller as well as our flash. This flash is going to contain the firmware, and the main microcontroller is going to be running the main OS as well as handling the ISP for the camera and the main video processing. This chipset, whilst we don't know what it is right now, is likely going to be similar to something like the SSC338 used in OpenIPC. It might actually likely be something a lot newer than that, but the basics are this chipset is going to be handling the operating system as well as the image processing, taking up that job, as I mentioned, in the DJI FPV 03 and 04 system of the video side of things, and then CaddX are going to have a separate RF chipset. Looking on the other side of the board, whilst this image isn't as clear, it still actually tells us quite a lot. For instance, here we have our MIPI connection for our camera, which will be going into that main chipset on the other side. We then have our RF chipset over here, our RF power amplifier, as well as our antenna UFL connection. This RF chipset is where things get interesting because CaddX have been hinting that they are using a new chip, a new in-house chipset has been suggested to me. However, I am now able to share with you that we now know what this chipset is, and it is another one from Artisan. Specifically, the Artisan AR-Link 803x series. Now, this is a newer chipset from Artisan, specifically designed for wireless applications between 150 MHz and 7 GHz. We don't believe it's a straight SDR, and again, it is still based on the Artisan system. However, it is different to the original chipset because it doesn't have the big ARM cores on board. Instead, this is designed to be a separate modem and MUX chipset, and this is then paired to a chipset like I was describing earlier done in 03 and 04, or as I showed on that board on the other side, that handles the main OS, video ISP and processing. The very basics are, this is the RF baseband, the modem, but it also integrates the MUX into this chipset as well, which means they should also be able to save a bit of space on the board because they will no longer need to use that IE2000 chipset. It is a similar route to what DJI have taken. However, it is worth stressing that DJI is a full SDR. This is still believed to be fixed function. It's just a fixed function custom ASIC. But what it does do is separate off the video and OS from the RF side of things, and it is a much newer base system. Now, this chipset first appeared on the scene in 2023, although we didn't really see it appear in products till around 2024. There is a little bit of documentation out there on it. It is specifically designed for use in things like drones. They talk a little bit in some articles about where it's being used. You can see some products here, and there's also this image here, which is quite interesting, that gives you quite a good overview of what the setup of this is. And in fact, this is basically a blueprint for what you're going to be seeing in the VTX. So for instance, you can see you've got your main camera IC here, which takes your image input. You've then got any of your additional IO there, and then this connects to the AR-Link 803 time series via USB 2, SDIO, Ethernet, whatever choice is. You can see this has got its RISC-V core on board, it's got its baseband, and it's got its transceiver on board as well. And as I mentioned already, the really interesting thing is you don't need the separate IE2000 chipset when you use this. So again, if we look on my FPV wiki where I was showing you pictures of the VTX, you can see this chipset here. This will no longer be needed. Instead, that RF baseband will do the job of this, but you're still going to need a main processor. So whilst this chipset in some ways replaces this chipset, it's adding another chipset because it in itself is no longer part of the main microcontroller. But as I mentioned earlier, this in some ways is a similar setup to what you've seen from the likes of OpenIPC. For instance, OpenIPC uses the camera IC, maybe the SSC338 series. That chipset handles the camera, has the onboard OS, and then that offloads to Wi-Fi, whereas in this case, it will offload to the AR-Link chipset. In theory, CaddX will be able to choose any chipset they want for the main OS and video processing. They may use something like that from SigmaStar. They could even, though, use something much more powerful like a smartphone IC to handle that side of things, like we've seen in the likes of these little action cameras from DJI that are now using chipsets from Qualcomm. The advantage to this for CaddX is that they can pair up this RF chipset with the microcontroller of their choice depending on the application. So if they're building a very cheap system, they can use a cheap low-cost microcontroller, and if they're building a more high-end system where they're going to want high-quality onboard DVR recording like we've got on 04, they can choose a more expensive chipset. Separating off the main microcontroller from the RF side of things gives more options. It means that you can tailor your product depending on the price point, the use case, and you can actually swap out different parts of the system depending on your needs. CaddX are not the first to be using this chipset. It has been around a little while, popping up in products from the likes of Hubsan as well as Potensic. There are FCC filings where you can see this chipset is clearly shown. Just something to note is that in some of the early FCC filings, the chipset is labeled exactly as it is. However, in later FCC filings and what you will find in the CaddX VTX is that the chipset is actually labeled differently. This is quite normal. Sometimes the early chipsets are labeled exactly what they are, but actual production chipsets have a different set of labeling. Don't worry, we've been able to identify it as a result of that, as I'll show you in a minute. But here you can see the actual chipset is labeled Artisan AR803232. This is the version used in the Potensic remote controller. If we then hop over to the drone, you can see it located down there. In this setup, you can see they've got their main microcontroller up here. You've then simply got then the Artisan chipset and then your power amplifiers. You'll notice there's no IE1000 or IE2000. It's a really quite simple setup. And again, just to give you an idea of the sheer size of this chipset, you can see there the two small power amplifiers as well as that chipset there. So it is surprisingly small. The chipset will be labeled V2 with these numbers shown along the bottom. This image here is actually from inside the Potensic drone, showing you the actual chipset used. So again, whilst the FCC filings show you the Artisan name. The actual chipset mask and name is different. Artisan have a habit of doing this actually. They're not always keen on seeing their product's name being shown out into the world, especially by people like me who highlight where they're being used. So what you should expect to find in the VTX is this on the RF side of the board. Don't worry if these numbers don't match, that's just production info. The important thing to understand is that it is this chipset here. So as you can see, there's an awful lot to unpack here. We have a new drone, but we also have a new digital FPV system. Obviously, as I've said already, I can't comment on the drone. I don't have one. I intend to buy it when it releases. When it does, I'll be then doing a review. I'll be talking about the product, but that will be a bit down the line from the guys who've had it for some time already. That $359 price point is extremely aggressive. You've got drone, goggles, and remote controller in that. Goggles look to be based around the Goggles L. Isn't clear if they're using 2 or 4 antennas like on Avatar HD, and the reason I've highlighted that is there may be a bit of a limitation around that chipset in this regard, which I'll talk about in a minute. The drone itself, again, we don't know the exact details of what firmware it's using. Probably PX4. Betaflight doesn't make sense because it doesn't have good optical flow support unless CaddX have modified it to include it. The remote controller is based around ExpressRS, and all the information I have right now is that there is no official target. The ExpressRS dev team haven't been sent a sample, and if that's the case, whilst it'll run ExpressRS, it won't be officially supported by the ExpressRS dev team. But the upside to that is that you can use your own remote controller with the drone. The FPV system itself, though, is where things get really interesting. We have already seen some leaked footage of what it looks like, but again, it's early days. We don't really have detail on exactly what it's like. It's got some interesting behavior though. So for instance, the image goes from color to black and white as the signal starts to drop, and then it moves down into that center section. It's like an extreme focus mode, but rather than blurring the sides up, it actually just completely cuts the sides off, and that is what is going to be different compared to how it works on other systems. With regards to the system, the main electronics, again, as I've said, we don't know what the main microcontroller is. It's extremely unlikely to 0 chance that CaddX taped out their own because it makes no sense to do that. There are loads of video processing ICs out there. The way CaddX can do it here is they can choose a low-cost budget one for the entry-level system, or then build a more higher-end system based around a higher-end micro. We have, though, the Artisan chipset there for the RF side of things. This AR830 time series, same as being used in this drone here. Decoupled now from the main microcontroller, but it is still AR-Link. It is still Avatar HD's base system that Artisan created, although it isn't Avatar HD. Technically, though, and I am going to put this out there, I don't see why they might not be compatible, but I don't know enough about it to say things 100%. I actually think what CaddX have done here is a good move. This allows them to decouple, as I've said already. It will allow them to develop the system. This chipset can do up to 160 megabits a second, although we are very light on technical details on this chipset in the sense of we don't know what its maximum bandwidth is. From the technical information I've seen, it only supports 2 antenna lanes as well, but that might simply be the only thing that's being shown. As I said earlier, this chipset does integrate the MUX on board, and whilst that's a good thing from a packaging perspective, that may not actually be a good thing from a system perspective at times. So for instance, in the goggles, CaddX use the Artisan chipset with 2 of the IE2000 chipsets, allowing them to use 4 antennas, but this new RF front-end chip has the baseband and the MUX built in, and if it is limited to 2 antennas, that means the system is always going to be limited to 2 antennas, although that isn't to say that you couldn't pair 2 of them together. Not sure how that's going to work though, because it is the baseband, or you might be able to attach an external MUX to it as well. Or there is a third option that you use power amplifiers with built-in switching and do more traditional diversity rather than the kind of spatial diversity that you get in the current system. Right now, we don't actually know that much about this new AR-Link chipset other than the fact that we know it's in drones like this. We've seen it being used in various pretty low-end products, but that isn't to say that it doesn't offer a lot of capabilities. What is interesting, though, is the fact that this isn't something entirely new. CaddX are still within the Artisan family, and as a result of that, they are still playing in the Artisan walled garden. Artisan is not a complete SDR as far as we know, still loosely based on WiMAX. As a result of that, CaddX are still going to be taking what Artisan have put together and using the building blocks. Think of it a bit like Lego, whereas DJI have completely designed their system from the ground up. In the end, though, I have to say, I don't think there's anything bad here. And what's interesting is to see how CaddX develop this, because this is going to put a lot more in their hands, but they're going to have to now develop this system pushing forward. As I've said already, it isn't a direct replacement for Avatar HD today, but that isn't to say it couldn't be in the future, because all they now need to do, and I say all quite loosely, but what they need to do maybe now is take the RF chipset, pair it to a nice big smartphone SoC, which will do high-end video ISP local recording, and CaddX may be able to bring the fight a little bit to DJI O4. However, it's going to take a lot of effort. So that's everything I know, at least. Hopefully you know a bit more now as well. If you have found this video interesting and you'd like to support the channel, please do consider checking out the link to my Patreon as well as buy me a coffee. It is only through the support of my Patreons that we're able to keep making content on this channel. And if you'd like to support us, please do consider checking it out. I want to say a huge thank you to all of my Patreons. We would not be able to do this without your support. Anyway, that's it. Stay safe, off the Christmas card list, and I will speak to you soon.